Now, when we're thinking emerging trends in construction, we've already spoken about jobs and roles, and we've spoken about the sorts of things that the industry is responsible for in Australia and how the construction industry interrelates with those other industries. In this section of the syllabus and in this section of the lectures, we're really looking at all of the new technologies that are currently either just released or about to be released that are being used in the construction industry in really innovative ways and changing the way that work is done. So we're going to be looking at technologies, we're going to be looking at upgrading skills, we're going to talk about some of the professional development associated, but we do have a whole heap of slides associated with that and where we get that information from. So to get started, by the end of this lesson, this is your know, understand and do, you're going to know a variety of emerging technologies that are beginning to enter the construction industry. You're going to understand how each emerging technology can improve the construction quality, efficiency, safety, or productivity. So every one of these technologies has to improve something, otherwise there's no point in adopting it. And lastly, there is a margin question activities on emerging technologies in construction that we're going to ask you to complete. So that's an article you read through and some answers associated with that. So we'll get started on augmented reality. Now, before I begin talking the construction applications, I'll just refresh you. Augmented reality is that process where you are able to put the digital or virtual world onto the real world using camera technology interwoven with the interacted with the virtual world. Okay? Virtual reality is a completely digital world. Augmented reality is a combination of the digital world merging and integrating with the real world. So if you were one of those people that was playing Pokemon Go, or you're aware of people playing Pokemon Go and they were able to put Pokemon into the streets that they were walking along using their phone's camera, that's exactly what we're talking about with augmented reality. So we talk about now the construction applications, and there are huge implications of how this can be used and how this is already being used. So I guess when we're looking at the augmented reality, we can think of, imagine having your camera at a job site, your phone camera, and you just look at a certain wall and you can say turn on electrical and plumbing. And then it will overlay where all the cables and all the pipes are placed inside of those walls. Now, for this to work effectively, there is a huge importance placed on actually having our buildings built very precisely to the plans. Okay? Because obviously if the pipes are in a slightly different location than the plans, using this augmented reality is going to mean you're going to potentially drill in the wrong spot or endanger people when they might drill into electrical cables when they think potentially the wall should be clear. So it actually has massively increased the importance of precision in building, but it's also added some benefits of efficiency of locating where sources and resources are. Okay? Now, it can't just be used for electrical and plumbing. It can be used to help a client understand what an empty factory is going to look like after all of the building works have been completed. Okay, so remember, it's not just linked to plumbing and electrical like you can see in the image there, but it can overlay all sorts of different layers, including finishes, furnitures, etc. We're starting to see this happen in the commercial setting, where people are able to go to furniture stores now and overlay their furniture into their living room using a combination of augmented reality with photos of their real living room. So that's a reality of some of the ways it's being used. The last one I'm going to point you to is Woollahra Council. They've got this new 3D technology that they're working on for urban planning. So previously you had to do your development applications, and your development applications would then go to council, someone would review them, your architect had to needed to consider how shadows are going to impact on other buildings, etc., in sort of a really theoretical sense, because there was no single database that had all of the building plans built in. Well, Woollahra Council are starting to do that, and I've got a very small screenshot on the bottom of the screen there, but effectively they've combined satellite imagery, or Google Maps for example, with their 3D plans of all of the commercial properties in their council area, so that as you zoom into the area, you can actually see buildings start to pop up in 3D as built buildings, and you can see exactly where shadows are at different times of day, how it's going to interact with traffic, and how your building is going to fit in with the rest of the urban landscape. So that's one example. If you have a click on that link, it's really cool technology. You can zoom in and see all sorts of different things. Give it a while to load because it's got to load a whole heap of information for those 3D models to work. But it is a pretty cool experience of how augmented reality is starting to look very realistic in our world. The last one here, we're talking about cloud technology. Now, cloud technology really is where we basically store data inside of servers that are accessible over the internet, and so this is where cloud technology comes from. It means that you might have a Google Drive or an iCloud Drive, for example, where you can access all of your resources from anywhere as long as you have internet connection. Now, where this is becoming really useful might be for sharing of data. If you've got a job site on one side of the country and your architectural firm might be on the other side of the country, rather than having to visit every week or every month to see how things are progressing, you might be able to use cloud technology to generate all your reports, to share, upload, download photos of the progression of the project. You could even see receipts, what sort of deliveries are happening today, the schedule for the day, the work schedule, who's on site, who's off site. There's a whole heap of information that could be stored in the cloud if the system is set up. Now, some of the ways that this is being used at the moment is photos of job sites, okay, where we can prove that work is being done. There was one example that I'll refer you to called Unearth. Unearth is a construction company. They were contracted by the council in their city to excavate a stormwater dam. Now, they didn't want to hire a new survey crew, so the city took bids based on the survey data from 1970. So they're using old data on how big the land was and how high the land was in terms of how much land needed to be removed. Now, obviously, when they're excavating, because this was old data, the contractor or the builder responsible very quickly realized they were pulling out more dirt than they had originally planned. So he filed a change order, which is where he lets the client, the council, know, hey, this is going to cost more than you expected. Now, work continued and the city agreed to address the change later, and the contractor kept tickets for all of the trucks coming in and coming out of the site. After the project was finished, the city then said, hey, we're not going to pay that because even though you've got proof that all of your trucks were coming in and coming out, we actually think you're only half filling them because you're trying to get more money out of us. Thanks to using this program called Unearth, this cloud technology Unearth, they were regularly capturing satellite or aerial images of the site. So the contractor not only had the tickets to prove that the trucks had been in and out of the site removing soil, but they had photographic evidence that they had stored in the cloud to prove that the trucks were actually full. You can see those photos on the screen there. Now, the benefit of that is they're able to measure how much of the area had been removed because the aerial photos they'd taken had collected the correct amount of data that was actually recording how much soil was being removed in that area as well. And because of this evidence that had been collected, stored in the cloud for a later date, the company that had been working on this, the contracted company, actually ended up getting all of the money because the city was able to see that they had used the resources efficiently and effectively, and they just happened to cost a little bit more. Now, without having that documented progress, those photos being taken and being stored in the cloud, they would have spent months or even thousands of dollars in court trying to prove what was actually correct anyway. So the cost savings on that side of things was enough to justify using cloud technology and the investment that comes with that. Things like drones to capture the photography, things like paying for the storage space, things like the software and the hardware to actually make it all work. So there's some of the benefits there of cloud technology. Okay. Some of the other ways it can be used to contain a database of your compliance requirements. So things like all of the certificates of occupancy, your certificates of currency, your insurance, etc., etc., etc. Could be the tickets for each of the workers, whether they're allowed to work at heights, whether they're allowed to work in excavated holes, whether they're allowed to use cranes, etc. All of the white cards for all of your workers. So if you have a safe work inspection, you can produce all of that using your cloud database. That leads very closely then into connected job sites. Now, connected job sites are where these job sites, potentially using cloud technology, are then connected with all of the key players. So it's not just about the builder having a record of everything being stored in the cloud, but it's about everyone being able to access it. So the architect being able to see the progress, being able to add files and view files that other people have added. Same with the engineer, the project manager, each of the workers being able to see the files that they need, potentially the plans for the different areas they're working on, as well as the client to track the progress and see how things are progressing compared to the schedule. Okay. Now, the benefit of this is you don't have printed plans anymore, or you don't need printed plans anymore. If you can access them all on a tablet and everyone has access to this connected system, well, then there's no issue of version control, because every time the drawings are updated, you just delete the old version from the cloud, update the new version, and then everyone only has access to the new version. So that's connected job sites, and it's really taking the cloud technology and making sure everyone has the right access. We can then start talking about wearable technologies as well. Now, wearable technology, I'm thinking right now I'm wearing an Apple iWatch, so that's a wearable technology. But anything like that that you are able to wear that is able to either provide you with data or collect data can be considered here in this wearable technology. Now, the benefit of this is keeping workers safe. We can monitor things like how's their heart rate going. We're able to monitor things like how long they've been standing for, when was the last time they took a break, how much work have they done today, what's the temperature like in the area that they're at, are they in danger, has there been a alarm activated, and do we need to notify our workers using this wearable technology? And then we think about other things like, could we use the wearable technology to read the instructions out for how to install different parts of a specific piece of equipment? Okay, all of this advanced technology, why not use it? It could even keep track of where workers are when accidents happen. So if we had different sensors around the building, we'd be able to work out what floor they're on, we'd be able to work out what room they're in that floor, so that when there's an emergency, let's say a building collapse, we might be able to locate exactly where they are using GPS technology. And then we start thinking about, okay, well, what about artificial intelligence? How can this improve and start to change the way things come? And potentially this might become mandatory, because this artificial intelligence can start thinking about potential dangers that might be coming up based on the number of people that might be on a scaffolding overloading it, or the weight of a delivery that's just been delivered and how that might be impacting on structural integrity, things like that. So artificial intelligence can start playing a role. And this is where the wearable technology is built into that connected job site that's linked up to that cloud technology. So it's all those technologies, 3 technologies, all linking together. Next, we're talking about drones. Now, drones is a pretty cool one that's coming up, but basically you can use drones not only just to fly around and be cool or to just take aerial photos, but depending on the sensors and the different technology that you put on the drone, you can actually record heights data of land, so you can do all of your surveying using an automated drone. Now, the benefit of a drone is it's significantly faster. So instead of taking potentially a couple of days to do a survey of a bit of land, you might be able to do this in a couple of minutes. And this is because the drone is able to instantly capture the data, store it to the cloud, instantly capture the data, store it to the cloud, move very, very fast, and it doesn't have to constantly pick up its equipment, set it all up, test that it's working, and then start capturing measurements. It can just continue to move around. The benefit of this, extremely accurate, okay, and a lot more data than you would normally get, which increases the accuracy of things, but it also increases the amount of data that you need to use. So potentially if we're looking at how jobs interact there, surveyors might need to consider retraining in the use of drones, but they also might need to retrain in the use of understanding and manipulating all of the data they're getting to be usable. Okay? The other benefit of drones is they can map areas that might be accessible. So potentially really steep cliff faces that someone might be working near. A drone can be used to map all of those sorts of difficult areas. You can see an image on the screen of one of those drones. You can also see an image of the sorts of aerial photos that can be captured and how they can then be combined together to create 2D and 3D maps. Now, the performance and type of drone, the components that it uses, the camera resolution, the height that it flies, all of those things will influence the accuracy. So if you want extremely accurate, you're probably going to have to spend a lot more money on the technology that you've got and the type of drone that you've got. But at the moment, it is possible to get your accuracy down to 1 centimeter. Okay, so when they're measuring things, they are accurate within 10 millimeters. Okay, that's enormous. Okay? We're also talking about accuracy around about 7 millimeters per pixel. Okay? And under optimal conditions are potentially better. Okay, now this is one particular drone. It's the Wingtra drone that is able to achieve that. And it's a high-end surveying drone, probably costs several thousands of dollars. Okay? But that accuracy of 10 mils and up to 7 mils of accuracy is extremely valuable when we're talking about surveying technologies and really making sure that we're doing a really good job of surveying to make sure that the foundations are set correctly. We've also got BIM, or Building Information Modeling. This is technology that you are familiar with. Okay, SketchUp, for example, is a type of BIM because it includes 2D and 3D drawings. But where BIM is starting to extend and is becoming separate from CAD is where it starts to include 4D, 5D, 6D, 7D, 8D, etc. Now, what I mean by that is you can open a 3D model and you can look at it from different positions. You can look at it from different times of day to see shadows and how it's going to look at different times of day and where the sun's going to reflect, etc. You can look at it in terms of the progression along the building schedule, so the as-built operation. You can look at the final product. You could look at the sustainability features. You could look at just the safety features. You could pull out all of the different layers in terms of just show me the hydraulic system, or just show me the electrical system, or just show me the structural system, show me the forces at this particular point. There's a whole heap of information that can be included. Because all of this data is now actually being stored in our CAD software, and our CAD software is getting more and more advanced with the amount of data that it is storing, we're now able to pull that out and use it in useful ways that enables not only the client to visualize what's happening, but also for the builders and the structural engineers to understand how things are progressing and where things might have stress points, for example. Now, this is modeling technology, so it's effectively the same as CAD, but it's just enhancing it that little bit more with those extra dimensions of information that are being included. The last one here is robotics. Now, there's a video there that you can watch. I've included that in the lecture notes for you to have a look at. But effectively, we think about how robotics is changing the construction industry. Now, in a traditional world, building a house, you've got a whole heap of builders out on job site. They get a delivery of timber. They need to knock up a wall frame. Then they install it to the house. They brace it up and then continue doing that until their house is built. When we think of robotics, we think of off-site manufacturing. We might be able to think about frames being built by robotic arms to millimeter precision, extremely square, extremely accurate, able to pick the timber up themselves, able to turn the timbers around, able to screw or nail as required, able to cut to length, all of those sorts of things, all automated. Benefit of that, there's less danger to the workers. Okay. Problem with that, well, it means workers might be losing their jobs, but it also then creates new jobs because someone has to program these machines, someone has to monitor these machines, and someone needs to run the factory. So there are changing nature of jobs. We also think about on-site production. There is in this video that you're able to watch, there is a robot that is able to build a brick wall. Picks bricks up, puts the mortar on them, places them. And it can build basically in an unlimited fashion based on the size that it can reach. I've seen 3D printing of concrete using robotic arms as well, where concrete is being pumped into a robotic arm that is moving around and printing effectively or laying concrete in layers, sort of like brick layers, around the perimeter of a house to create that wall. So there's a whole heap of changes coming in terms of robotics and how that's impacting the construction industry. So that's the end of that set of slides. I hope that's been really helpful and beneficial for you. Like I said, there is a margin questions activity for you to work on. Good luck with it, and hope that was helpful.